Clearing senescent cells, often dubbed zombie cells, is rapidly emerging as one of the most promising strategies for addressing chronic pain not just superficially, but at its biological root. These cells, which have ceased dividing but stubbornly resist death, linger in the body and excrete a toxic mix of inflammatory chemicals known as the senescence-associated secretory phenotype, SASP. While this process originally evolved as a protective mechanism against cancer and tissue damage, in the context of aging and disease, it begins to turn against the body, fueling low-grade chronic inflammation, tissue degradation, and pain sensitivity. By targeting and eliminating these cells, researchers believe we may be unlocking a transformative tool for not just managing chronic pain, but reversing the processes that drive it. For decades, chronic pain has been treated primarily through a lens of symptom suppression. Opioids, NSAIDs, antidepressants, nerve blockers, and even surgical interventions have dominated the clinical approach. While these strategies offer temporary relief, they often fail to resolve the deeper, systemic contributors to pain, particularly in conditions like osteoarthritis, fibromyalgia, intervertebral disc degeneration, or neuropathic pain syndromes. What sets senescent cell clearance apart is that it represents a shift in philosophy, from reactive treatment to proactive regeneration. Instead of simply dulling pain signals, this method aims to address the underlying dysfunction at the cellular and tissue level. One of the most compelling aspects of this approach is the discovery that senescent cells accumulate in areas of mechanical stress, injury, and inflammation, exactly where chronic pain tends to originate. In animal models, removing these cells from aged or damaged tissues has resulted in striking benefits: reduced inflammation, improved mobility, and even nerve regeneration. In models of osteoarthritis, for example, senolytic drugs, compounds that selectively destroy senescent cells, have not only alleviated pain but also appeared to halt the degenerative process in the joints. This suggests that senescent cell clearance is not merely a painkiller, but a potential disease-modifying therapy. Importantly, senolytics may also act synergistically with the body's natural healing mechanisms. Once the burden of zombie cells is lifted, tissues often regain some of their youthful functionality. This includes improved mitochondrial health, more balanced immune activity, and the return of a healthier cellular neighborhood. Rather than perpetuating inflammation and damage, cleared tissues may become more receptive to regeneration, paving the way for better function and less pain over time. This could be especially impactful in aging populations, where the accumulation of senescent cells is one of the main drivers of tissue fragility, delayed healing, and chronic discomfort. Moreover, the growing field of senotherapeutics, which includes not just senolytics but also xenomorphics, compounds that suppress harmful signals from senescent cells, is expanding rapidly. Natural compounds like quercetin and fisetin, already present in many fruits and vegetables, have shown senolytic activity in preclinical studies. Meanwhile, pharmaceutical agents like dasatinib, navitoclax, and other emerging drugs are being tested in human trials with the hope of refining safety, dosing, and long-term efficacy. As research deepens, it's likely that treatment will become more personalized, tailored to an individual's senescence burden, genetic background, and pain phenotype. The implications go beyond musculoskeletal pain. There's mounting evidence that senescent cells contribute to neuropathic pain, possibly by altering glial cell function in the spinal cord and brain. This offers a tantalizing possibility that clearing senescent cells could help reduce the hypersensitivity and central sensitization that make pain feel worse than it should. It also invites exploration into their role in other complex syndromes, like chronic fatigue, long COVID, and even migraine, where persistent inflammation and immune dysregulation play a major role. Perhaps most exciting is the shift in how we view pain itself. If chronic pain is not just a symptom, but a manifestation of deeper biological aging and cellular dysfunction, then addressing these upstream causes offers a radically different therapeutic opportunity. By treating pain at the level of cellular resilience, we might not only improve comfort but extend mobility, independence, and quality of life for millions living with persistent discomfort. In sum, the strategy of clearing senescent cells offers a bright and fundamentally optimistic vision for the future of chronic pain treatment. It promises not just relief, but renewal, moving beyond symptom management into the realm of true healing. With further clinical validation and responsible development, senolytic therapies may soon become a cornerstone of regenerative medicine, helping people live not just longer, but with less pain and greater vitality throughout life.